are back. So we have yet another location. Well, it's almost the same location. It's just different floors. But
no, it's a totally different location.
It's a totally different location. Yes, fantastic. But we're
it's
still
like a week. My whole washing cycle is over. I have the same shirt again.
I know.
You too, I see.
Me too. So you do this. I guess we have the same washing cycle.
Yeah, maybe. Yeah.
Perfect. Fantastic. It's great
Washing
minds.
cycle buddies.
Great minds. Minds think alike, right? Okay, well, anyway, so jokes aside, I mean, things might be different, but, well, one thing is the same. We still have Nicolai with us, and we're still talking about Java. So we did have a session about all the fun things and module systems and JDEPs and JLink and all the other fun stuff that we did talk in a previous episode. So we're doing another episode now, and I think we should mention a few features, because we did talk about people being on Java 8, we did talk about like people going over to 9, 11, and so on and so on. I think the thing that we did not talk much about is the features that are coming up. So we have what? We have 13 coming in less than a month. Well, almost a month-ish.
Yeah, something like that.
Okay, give or take a few days. And let's talk about, well, I mean, we did talk about the kind of the big bang thing with Java 9 and modules and stuff. What happened afterwards? Yeah. So we should probably mention some other stuff. It's not only modules, is it?
Yeah, and I think that that's important to do because, we discussed modules, and modules is more like a seatbelt. Right. Nobody buys a car because they're great seatbelts, right? So if you want to, like, technically we do this for a living and it's a job, and we should just do it with equal enthusiasm no matter what really we're using, but that's not how we actually work. And so you probably need an incentive to select something to look forward to update to 9 and then beyond, right? Because the big bump is 9, but then afterwards it's pretty trivial to update. And so it's really, what do you get for your troubles, right? If it is even trouble. But assuming that it is a little bit of trouble and you put in the work,
for the time you spend, right?
Yeah.
No troubles, no troubles, that's another story. Yeah. But for the time you're spending, right?
So the first thing to note is that each individual Java release after 9 looks like meh. Because every individual one is rather small. But already now, if you put them together, if you take a Java 8 code base, and you apply the language features and the APIs that came with 9 to 13, if you apply all of them at once, you will already see a considerable difference. Yeah. And actually, that's something I'm planning to talk about that next year. I want to basically tell you, like, look, you think this is amazing Java 8 code? Let me show how much more amazing it is with all the new stuff that we can do. And because there is a bunch of new things that really will change Java development, not like in a fundamental way like Lambdas and even the module system. Lambdas taught us about what does it mean to program in a functional way. That's like a fundamental change.
And well, I mean, after all, it was a feature that most of the languages had for quite some time, and then it was like, well, it was about time to bring that as well
as well, right?
Right.
Well, that's right. But still, the thing is, like, Lambdas taught us about what functional programming means. So it was like a deep change. And then the module system will teach us about modularity. I'm sure about that. Even if people like fight it tooth and nail, some of them at least do. It will teach us something about that. Right. The newer features are not really like that. They're not like the ones that we saw so far. They're not going to fundamentally change how we approach Java programming, but they will change how Java code looks. Exactly. VAR is a perfect example for that. Like,
VAR is fun.
VAR is very interesting because at first it feels like, okay, so I'm saving a couple of keystrokes and everybody can't read my code. How is that good?
It was for me, it was a bit kind of my own kind of internal joke in my head, at least, that is kind of a bit funny for myself, at least, is that like a lot of people confuse Java and JavaScript, that outside Java world they say like, oh yeah, you do this JavaScript thing, right? And then you're like, no, it's totally different. It's like you try to actually explain everything, and then they introduce VAR, right?
That's true. Like, so what's the big difference? Well, they have const and we don't. which we don't, which kind of sucks. So,
yeah, but well, okay, jokes aside.
That's something maybe that I could explain, by the way. So there was enthusiasm for VAR, at least one. So, by the way, if you think VAR is a stupid feature and shouldn't be here, and why on earth is that a thing in Java? If you have that kind of opinion, like if you feel strongly about new language changes, then there's a way for you to make yourself heard beforehand. So, for example, for VAR, there were a couple of surveys that were made by the Oracle team, And I think a couple thousand people participated in each. So it wasn't like of course it's not representative, right?
Yeah,
because
yeah.
they were announced on Twitter, on conferences, on blogs, and on everywhere basically.
Yeah, yeah.
But not
I
every
remember
developer
that,
listens
yeah.
to those channels, right?
Yes.
So it's understandable that more of the more interested, more leading edge kind of people were getting those news, and then I think that skewed definitely the results. But the results were overwhelming. Everybody likes VAR. That was the result of those surveys pretty clearly. Like 80-90% of the people wanted to have VAR. But the consensus fell apart when we wanted, okay, now we have VAR for variables. What we want to do for final variables, essentially.
Yes.
What we now have to do final VAR. We would do val. Some people say like, oh no, val is bad, like because val almost looks like VAR. To me, that's an upside. But what you know, but with const or let. So the interesting thing is that the vast majority of people who wanted to have VAR, that majority balkanized basically into tons of different opinions about VAR plus what. And that is the reason why we only have VAR, and we have to actually write final VAR if you want to have something in final. That may change in the future, but the basic, what the JDK team said is, look, first of all, there's no consensus on what this other thing could be, although I would guess that often there's no consensus on what something could be, and still they pick something. The other thing is they say, and that's all true, is there are lots of places where mutability and not being able to reassign something is very important. Local variables actually are the least important of those. I'm not saying they're not important, but really, like, if you have a 5 to 10 lines method, it's much easier to keep track of not reassigning stuff and have your IDE warn about that than like if you have a field, for example. So yeah, I kind of agree. I like immutability and not being able to reassign stuff. So I get it, but it's true. Like within a method, it's maybe not that important. So that's how we got that variant of VAR. And the other cool thing about VAR is that, I talked about readability in the beginning, right? Let's continue that thread.
Yeah, the comments and stuff, right? Yeah.
No, I meant like, well, because at first it seems like you save keystrokes and then you can't read your code anymore. Awesome. Yeah. But that's not, well, you could use it that way. If your variable names are called you and your methods are called do it, then you kind of get into problems there.
Yeah.
But if you have good variable names and good method names, and yes, even good type names, because you will often see the constructor on the right-hand side, then I think VAR can improve readability by, first of all, it removes redundancy, because you have URL foo is new URL, which is not bad because URL is a short class, right? But if you start with list of my enterprise type of this one thing and this other thing, and then close the two angles, so now the type name is like this long, and your variable name starts at character 70 or something. And yes, sometimes the type information is crucial and should be there.
Yeah, enterprise software is full of that kind of stuff, isn't it?
And that makes code harder to read because like you don't. For example, I've used Kotlin a little bit, and the thing that Kotlin does very nicely, it starts with var, then with the variable name, and then you could put in a colon and you can still put in the type.
Right.
The interesting bit about that is that it aligns variable names at the beginning, and those are really kind of important. If you choose good variable names, they can tell a kind of story. So on my slides, I have this thing where I show people a bunch of code and say, look, the names are long, and you have to make new lines on slides. It's even worse, right? Because slides are smaller. And so it's really hard to see the variable names. And then I talk a little bit about var. Then I put in var and I show the same slides again. And like, I never had anybody come up to me and said, no, I got that the first time, but actually the variable names say no more jumping variable names from top to bottom. So they clearly tell a story that I would say nobody or close to nobody sees on the real example.
Right.
And the reason for that is the alignment, of course, but also var is a kind of keyword. It's a keyword light. But it's highlighted like a keyword for your IDE by your IDE. And I think most of us are kind of used to being able to selectively just not see keywords and then only see keywords and flip back and forth.
Right.
So you can just like ignore that part and just focus on the variable names.
And that's a good point because they're also actually aligned and everything. But also there is another thing that might be a bit different. Well, it's kind of not really different, but it's still kind of, it's not that you don't really have a type. It's just kind of you're hiding it in a way, right? Because the JVM in the background, it will actually try to deduct.
Not the JVM.
Well, not JVM, but the compiler. Yes.
That's very important, right? You made the JavaScript joke. We should address that. It's totally different.
Yeah.
This is only a compiler fiction. If you use your IDE and you write a couple lines of code and then replace that with var.
Yeah.
And then you look at the code at the class file and decompile it, which your IDE will do happily for you just by double clicking on the class file. You will then see decompiled bytecode which shows up as Java code. You will be hard pressed to find a difference between the Java code that you just wrote and before you replace it with var and the thing that gets decompiled, because the compiler will infer these types and put them in, and where it can't, and it is on purpose, it's very limited scope to deduct the type. It has to be on the right hand side. So the right hand side has to be there and has to define a type. So the best place for this is a constructor. A constructor clearly defines a type. It's very easy to see. Yes. And if you're very skeptical about using var, then that's a great place to start. Use it where the right-hand side has a constructor. Because then you usually type name foo is new, same type name. So there is very easily get rid of one of those type names. So the compiler would put in the type. And in places where it cannot decide that, you will get a compile error. For example, lambda expressions are so-called poly expression. A lambda expression doesn't have its own definitive type. If you write a arrow, a plus empty string or a space string, then a can be anything. Like there's no way to find out what is this, a function from string to string, or is it a function from object to string, or is it a unary operator of string? Could be anything. So the compiler doesn't know. If you put var on the left-hand side, the compiler will tell you, like, look, both sides don't have a type, help me here, do something. So there are a couple of cases where you cannot use var because of that reason. And that reason is not, well, lambda expressions aside, that reason is not that the compiler just couldn't. You could make it more complicated, you could make it infer more types, but that is not the purpose of var, because that would mean that you would have to do the same tricks in your steps in your apps if you read code without IDE.
So it's a good thing, and I've seen probably you've seen that as well. Pretty sure you've had people doing a lot of kind of gotchas at the conferences and stuff, saying like, what do you think the output of this will be, or what do you think what type of this thing will have? And sometimes it's kind of obvious, and sometimes you're like, wow. And then when you actually get to this wow thing, then probably you should not use var there, right?
Yes, and wow is nice in a conference talk, and wow is nice if you read like
it's
a
kind of an eye-opener, but not really good for readability at all.
And with var, you can do really great things, like in the sense of entertaining things that you should never use rarely use in code. One of them you can. So the thing is, with var, you can, with var and generics, it's mostly the generics doing the work, but the var really help. You can simulate intersection types. You could actually use that. Like, it's very cumbersome, but you kind of like, sometimes if you're in a bind, you can combine two types without creating a new interface. I'm not going into details here, don't worry. But if you Google for var intersection types, you'll find a blog post I wrote about that. You can also use var to simulate traits. And that you should actually never, ever, ever use. Because if you do that, then the instances you create, they don't have the proper equals and hash code implementations. So if you know what traits are, if you have a type and you apply a trait to it in the weird var generics Java kind of way, then the thing that you create does not have the same equals method as the type you started with. And that means if you take the type you started with and one of these things and put them into a map as keys, nobody knows what happens. And you probably don't want that. So that's why traits are really nice to play around with and to impress your colleagues, but it's not something that can actually work in real life. And that's not what var was there for, right? But yeah, you can do these things. You can force these gotchas, and yes, you should be kind of aware of them so you don't accidentally repeat them. So for example, if you have long L as 0 and then you replace long with var, then you actually get an int. So you should be aware of that. But particularly on var, it's not that hard. And Stuart Marks, who works at Oracle, who worked on var, created some guidelines. First some guiding principles, and then concrete guidelines on what to do and what not to do. And then Simon Maple took that and worked together with Stuart Marks to turn to a cheat sheet. So just a single page teaches you like 95% of the things that you have to know about var. And that's a great way actually to start with a new feature. And that's a good thing to look forward to. And var will change the face of Java code. Maybe even more than actually lambda expressions, because they're kind of rare, right? You don't
it is.
Well, even in a stream pipeline, you have like 5 of them maybe. But with var, you could technically end up with having like 25 vars in every class. Maybe you shouldn't, but you could.
But it's actually very good also like a pointer to our listeners, people watching the podcast and everything. It's like what to look for and search for. And Stuart Marks, var guidelines. It's a good thing to search for, to Google for.
We can leave links there.
We can do that as well. And this is cool. So var is one thing, but there are a bunch of other things that we should probably mention. So one of them would be probably switch.
Switch became an expression.
Switch,
right?
yeah.
So switch expressions means that you can now assign a variable to the result of a switch.
Yeah.
That's pretty neat. That's one. Actually, there are two changes packaged into one. That's one change. Switch can be an expression, and you can still use that with case, whatever, colon, and then that stuff where you have to break in things.
When did we get that thing, by the way?
So it started in Java 12.
It's in 12, right?
Feature.
Yes.
It was refined in 13, so in 13 it's still a preview feature, which means you can write code against it only if you want to jump through a few hoops.
Right.
On purpose.
Right.
It hopefully gets finalized in 14. The thing is that with switch expressions, not only do you get this thing where switch becomes an expression, you can have a value, you can evaluate it to something which makes code shorter. You also have a new syntax. You don't have to use case, the value, and then a colon, and then you have to use break because you have fall through by default, which I guess made sense in the 80s or 90s, but not a good decision for enterprise code. Which is why the new syntax, which uses the arrow, doesn't have fall through. That alone is worth a lot to me. And if you know a little bit more about switch expressions and the two forms, my recommendation, my assumption is, and what I will do in the future as soon as I can work on that is, I will use switch as an expression or as a statement as it fits the code, but I will by default use the arrow form to get rid of the damn fall through, because I rarely need that. And if I do need that, then I can go back to the form that uses a colon.
Yeah, that's a good point.
Another thing we have is text blocks, just multi-line strings, pretty straightforward.
Yeah.
The only interesting bit there is how, like, if you have a multi-line strings, you probably have code indentation, right? That's good. So with multi-line strings, you probably have code indentation. Now, you don't want to have that indentation in your string.
Yeah.
So the interesting bit is, how does the compiler, because the compiler is in charge of turning that multi-line string into just a regular string literal, how does the compiler know which part of the indentation you want to get rid of,
right,
and which part of the indentation is there on purpose? Because if you have like a small HTML snippet, yeah, some parts of that are there on purpose for some part of the indentation.
Yeah.
That's another small detail that, like, it always amazes me how much work you have to put in to make something seem intuitive. Because if I show you how, if I just explain on a superficial level that some part of that indentation gets removed and some other part doesn't, show you a few examples, you'd say, yeah, that's straightforward. That makes sense. If you look at how that is computed, it's actually like a 6 or 7 step algorithm. Like, it's not really complex, but just 6 or 7 steps.
Yeah.
And you could technically you could reorder many of them, right? You could just try what if I do this way or that way.
Yeah.
And every reordering usually ends up in some cases being really counterintuitive, right?
Yeah.
So this it's not a complex algorithm again, but this algorithm has to be the way it is. And this algorithm has to be the way it is. And it's not exactly like that. You will get lots of counterintuitive results.
Yeah. So yeah, this algorithm has to be there, and it will.
Yeah, it gives you the result that you would expect. It determines what part of the indentation is on purpose, which part is not on purpose. Let's get rid of the parts that's not on purpose. That's just part of your code style.
Yeah.
But I find once again, like how much
energy
you have to put into it.
Yeah, but then I guess this kind of things should have. I mean, many languages have that already, and they probably have some kind of experiences and guidelines and stuff like that, and use cases. For example, Python has had the multi-line text blocks for, I don't know, as long as I remember, forever. Yeah. And now Java is having that. Now they call it text blocks instead. But, well, multi-line text.
I don't know why it's called text blocks.
I don't know. It's just probably, I have no idea either. But it's kind of the same thing, isn't it? There's like triple quotes, kind of the same thing that you have as a triple quotes in Python, right?
I'm not sure whether Python, are those raw strings? Are they interpolated? Like, can you put
no raw strings? Well, I mean, now
so I don't
it's
know Python a whole lot.
Yeah, the scary part of doing things, saying things when it's being recorded, then you can actually get quoted for that. But I think as far as
Rustam said that Python sucks and Java is awesome, or the other way around. I don't know.
I did not say such a thing. Well, I mean, I think that part is probably use whatever fits where. But the thing is that with raw strings, as far as I can remember, you would have like an R and quote, and then you'll have things in it, like with also Unicode strings and stuff like that. But with this multi-line thing, it will be like triple quotes usually. But then you will have, when you do multi-line, it also will do some fun with formatting and stuff like that. And it's I think since Python is taking all this indentation thing seriously, I think they will at least cut off all the kind of starting ones. But I'm not sure. The
interesting thing about Python,
I want to try that actually now.
Python indentation has semantics, right?
Yes.
So that would mean that Python has to know at any line what indentation has to be there.
Exactly, because otherwise it's like brackets in Java, right?
Yeah, and then you can simply kick that out.
Yeah,
right? So because
exactly, that's what I'm saying.
But the Java compiler doesn't know, right? You can indent things basically randomly.
So the thing that confused me right now, and I said that I want to test it out, is that what if you have some extra indentation? I don't know. I'm not really sure how it will respond there. But yeah, in Python.
So that's an interesting bit. And so in Java,
how it will be in Java then? Let's talk about that.
The most straightforward way to manage indentation of your string is you put the closing 3 quotation marks on its own line. You don't have to, but if you do that, well, first of all, the text block ends with a new line then. And sometimes that might not be what you want. But assuming you can take that, so the string can end with a new line. Then 3 quotation marks are on its own line. And then the Java compiler will use their indentation to determine what indentation is accidental coming from the code style.
So you can kind of take it from there.
Exactly. And then you can align relative to that. So then you can just take the entire, like this way, right? So you have the closing quotation marks here, and then you can take the entire text block and just indent it one more tab.
Yep.
Because you're using tabs.
Yeah,
right?
Yes.
Good.
Well, yeah.
You said yes. So there you go. You indent one more with the only true indentation that there is, and then the resulting string will actually reflect that indentation on all the lines, right?
Yes.
So that's a good way to manage. Where you're going is many other languages have these features. Why does Java have to reinvent them or rechange them or something? And I think,
that would be a natural thing for anybody listening to that to say. So that's why I'm kind of being the advocate of those people, I guess, and just.
So the thing is here at this point, like most of what I just told you, actually understood and can explain in detail. Now, if we go to this, what I'm just going to say now, I'm basically just repeating what the people at Oracle say, and it feels true. So I think it's truthy is what Stephen Colbert would say, but I cannot actually criticize that or support that.
Right.
What they say is, yes, it's true. Other languages have these features, but you cannot transplant features. Like every feature interacts with many other features. That depends on how you as a developer want to use those features and what expectations you already have because you're using just this one language maybe or just a few languages. So you have kind of like Java-y expectations in your head. That plays a role. Then how can the JVM or the compiler do that? How is it maintainable? How is it affordable in the sense of, look, var is a nice feature, but if they would have told you, look, we're doing nothing for 3 years until we have var done, then you would have said, like, what? Can I have something else instead, please?
Or it will say, I don't know, it's if you go like totally crazy, it might impact your performance or something like that, right? You will get like really bad performance because of this feature and nobody would really...
Right, so there are a lot of things that are specific to the language where you want to have that feature in. And apparently that shapes the feature a whole lot. Like, so that's the part where, once again, it makes sense. It sounds like it makes sense. But on the other hand, I feel like, really, is that, but, I mean, the number of quotation marks, for example, wouldn't that be something natural? But with the text blocks, I'm not that convinced of that specific thing, but in general I am. Like, for example, lambda expressions. Lambda expressions map to functional interfaces. And lots of people are crying over that. We should have top-level function types, and why don't we have those? First of all, there's a good talk by Brian Getz, Lambdas Under the Hood, where he explains why we don't have function types. But more than that, and I think they get very little credit for that, lambda expressions are forward compatible, right? So if you use the functional interface in Java 6, you call that code now. It's even compiled against Java 6 with a lambda expression. How amazing is that? Because this pattern of using this one abstract method interfaces as kind of a function existed in Java for years at that point. And lambdas, after trying other things, picked that up and ran with it and decided, let's do that all the way. And I get why people complain. I get why top-level function types do have advantages. But this is incredible that you can use all kinds of old APIs suddenly with lambdas. You don't have a big break between, yes, you have objects and primitives, but now you also have functions. So I think lambdas are a great example of where the feature cannot be like it is in other languages and then still expect it to work as well in Java, where you have to adapt it to the ecosystem, to the technological requirements. And I think they generally do a great job there. And I appreciate that.
It is. That's for sure. So this is all of these are really cool features. And but then we have also there are 3 more kind of features that I would really like to talk about, and those are kind of code names features kind of thing, right? And then you have what? You have Project Amber, Loom, Valhalla, right? Those 3. Well, there is more, but there are like at least those three we should probably mention.
So the reason why I focus on those three is because those are the three that I understand somewhat. Because Panama, for example, deals with native code, which I have no experience with. But Panama, if you're working with native code in the JVM, then apparently Panama is amazing. There's Metropolis, which I forget what it's doing. There's Graal, of course.
Yeah, of course. Yeah.
So there are a bunch of interesting projects.
Of course. But then
Amber. I think the reason why I know more about these three and why they're easier to understand is also because they're more surface level features, right?
Right.
Amber, and particularly Amber, which brought us var, which brought us switch expressions, which brought us text blocks, which will bring us more towards pattern matching, which will bring us records. It will most likely at some point finally kill damn serialization and replace it with something sensible. It might bring us concise method bodies, which essentially means if you're forwarding a method call, basically if all you do in your method is just forwarding to another, you might be able to write something like public int size, opening closing brackets, the lambda arrow list, the method reference, rep list, : size. So what that means is apparently I'm repping a list, and if you call size on me, just forward that call. So that looks really odd at the moment, but that's something that Amber might bring. I feel like I forgot one thing, but never mind.
So what is Amber in 2 words? Like just...
In 2. Productivity oriented.
Fantastic. That's
Brian, I expect your thank you letter anytime now. So, that was close. Like,
nice. That was really good.
It's not okay. I just quoted the first. So every of these projects has a goal, right?
Right.
I think Amber's goal or mission statement is productivity oriented language features, blah blah blah. So,
that's cheating.
I just quoted more or less. But yeah, still. So that's what Amber is about. Then we have Valhalla and Loom, and both of them are much bigger.
Right.
So Amber, I mean, every language change is expensive. Every language change takes time. But you can see how putting var in, which just exists in the compiler and which has simple rules to follow, kind of is simpler than what Loom is trying. Loom, for example, is trying to to give us fibers. Fibers are like threads, and ideally, to a Java developer, they behave exactly like a thread, meaning I can do the normal things. I can write code. It works in one thread, and then the method blocking. So my code looks like synchronous code.
Yeah. And threads, well, hence the Loom project name, right?
Yeah, thread, fiber.
Yes.
They might have they consider having a super type, which is then called a strand. So they're running out of words for that thing, I think. But yeah, the Loom is the right term there. So the idea behind fibers is you get something that behaves like a thread.
Right.
But it's not a thread because the thread is managed by the operating system. It's expensive to switch. It's expensive to have those around. You have about a megabyte of overhead per thread. So that means you can have thousands. You might be able to have millions, but you're unlikely to have billions of those.
Right.
And fibers ideally go against these 2 rules. We leave scheduling to the JVM because the JVM knows much more about JVM details than the operating system.
Exactly, right.
So it can be more clever when it comes to that. I really hope that more clever is the right way to say cleverer, because otherwise that was a bad word to get it wrong. So anyway, I wish it was more clever.
Cleverer, I think, is fantastic. Bestest and cleverer and all those kind of things that you should never say. But yeah, well, anyway.
So fibers are managed by the JVM, which knows more about what's going on. Then they are very cheap to switch, ideally, and they have almost no overhead. Ideally in the range of bytes, maybe kilobytes. If they're in the range of bytes, then you can actually have billions of those things.
Right.
And then you can write code that looks very simple. Here's my request. It comes in, somebody parses all the JSON into Java objects, whatever. I get my stuff. I do a little bit of things on my own. I pass it off to the database. I block. We're not actually blocking here. That's the important part. We can have billions of fibers, and if one of those blocks, it doesn't really cost a lot of resources, right?
Right.
Database call comes back. I prepare my response, send it out. Straightforward Java code. Debugs like synchronous code is really simple to write, simple to understand, will be like by a couple orders of magnitude more scalable. Basically, what the scalability you get is basically 1 megabyte is what the resources you need for a thread.
Okay, so the scalability and the thread. So you have the...
Right, so a thread essentially has 1 megabyte of overhead, and that's why you can only have so many of them. And then if we end up with fibers having 1 kilobyte of overhead, you can have 1,000 more. That's basically the rule of thumb of how much scalability you would get. And the crazy thing here is if everything works out perfectly as the Project Loom members envision, specifically Ron Presto is doing amazing work there. I thought also Alan Bateman and I forgot other guy's name, just also participated in the JVM LS talk. I think Rickard is the name. Anyway, if they manage to pull it off, ideally, Tomcat, for example, will simply switch on the Java 17 release or whatever contains Loom, right? So it will Tomcat will just detect, oh, I'm running on the Java version that already has Loom. Great. I'm just going to give you fibers instead of threads, and your code will not have to change, ideally. There's a problem with that, like we have thread locals and the native frames on the stack may cause problems. So there's no work to be done until we get there, or until they get there, really. But if that were to work out, that would be amazing, because you would get this totally for free. You would have to do nothing. You could just take your old application that has to run like 10 servers at the same time and just say, okay, we just got rid of 90% of our Amazon cost because we just use one application now, one instance now. So that would be pretty amazing if Loom can pull that off.
That's really cool. Yeah. That's a good thing. And then last thing, since we're kind of running out of time, Valhalla.
Yeah. In short, so I talked about Ember mentioning this thing called records, and what a record is, maybe Kotlin, it's a data class there. Most languages have that. You're basically saying, I have these two fields. Let's say I have three fields. I have a point. And I don't want to write the API. I don't want to write getters. I don't want to write constructors. I don't want to write equals, hash code, Lombok that for me. And that would be a record. In a record, you give up encapsulation. You give up your own choosing of your API, and in exchange, you get that code for free. That was a record does. I mentioned that because value types can seem very similar on the surface. But a value type is something different. Let's take a point again. With a value type, what you get with points is dense and flat memory layout. And that means at the moment, when let's say you make a small game, you need lots of points. And then if you write proper Java code, a point is a class. It has three doubles maybe for X, Y, Z.
Right.
And then if you're an array of points, you really only have an array of pointers that point somewhere into memory. And if you want to iterate over all the points, you're basically jumping all the way through memory, like cache miss after cache miss. And that takes a lot of time. For most Java programs, it doesn't really matter. But it would still be nice to have the performance, but for most, it's not critical. But there are a decent amount of Java programs where that performance is critical, and that's a big loss. So what they do now is they warp their code to become more performant.
Right.
And more often than not, developers warp their code to become more performant and either not becoming more performant at all or gaining performance in an area where we spend about 0.1% of the time, which is totally useless.
Yep.
So we have this trade-off between design and performance, or often it's a perceived trade-off, but this, in some cases, it's real trade-off of real tension. Valhalla will remove that tension, or mostly remove that tension by telling you, okay, so you want to have a point that's just these three doubles? Awesome. We're going to embed these three doubles everywhere I use the point. We're going to copy those around. Basically, you're writing your own int there.
Yeah.
That's also the marketing codes like a class, works like an int. So you can basically define something which more or less works like primitives.
Yeah.
And there, like, I guess every Java code base has like 10 to 50% of classes that just scream to be records or values. Like, I don't care about this thing. Like, I don't care about my API. I don't care about identity. That would be the value, the trade-off with Valhalla. These things don't have identity, which means just like two small ints of value 5, they are equal and they're also identical. That doesn't make a difference to...
but that makes sense.
But a big integer 5 and another big integer 5, while they're equal, they can be different. They cannot be identical.
Right.
But that doesn't make sense for values. So values, you don't have an identity, which frees up the JVM to do lots more of optimizations.
Yeah.
And you give that up, and you give up mutability, because you cannot change 5 to 6. You can replace 5 with 6, but you cannot change 5 to 6.
Right. Yeah, makes sense.
So you give up mutability, you give up identity, in exchange you get better performance.
Yeah.
And I think I have this hunch that many classes want to be a record and a value because they don't care about either. Like that same example, I use the same example for both to actually bring that point across, because both the point doesn't care about identity, but it also doesn't care about its API. It's just X, Y, Z. That's all. So most likely this would be an inline value record class. Nobody knows what these things would be called yet. At the moment, it's an inline class would be the values, and the other thing would be records. But there used to be sometimes at some point they would call data classes and values, so nobody knows what that would turn out. And then, probably because we're running out of time, I'm not going to go into that. The question is, okay, we can have an array list of int at the moment, and that's bearable because we don't really want to do a lot of things with int because it's kind of a stupid type, right? What am I going to do with that? But now I have points that I made myself, my own point values and other kind of values. And as I said, 10 to maybe 50% of the classes now are these values.
Yeah.
And now what? As soon as I put them into a collection, generics erase them, and then I get the normal box behavior, and then all my performance is gone. that would be ridiculous, because then the advantage would disappear immediately, because you cannot program a decent Java program without using generics. So if you would then say you get performance or generics, then again you have this trade-off. So we have to figure out how to have an array list of int be actually backed by an int array. So we can have an array list of point actually be backed by a point array and not by a box around point. And I think most of the complexity of Project Valhalla lies in that, in making that work, once again, within Java, within an existing community, an ecosystem of like billions of lines of code, ideally in a way that is perfectly backwards compatible. Maybe some things are even forwards compatible. Maybe even now, because we have this value-based classes in Java, like option is a value-based class, and that means it wants to be a value, but it can't be yet. So then the question is, okay, how can we turn this into a value if we get values, and how would that story look? So like this, I think Valhalla is the most complex project of the ones that I know. So these three,
it is definitely, yes.
Maybe I'm not sure about Panama and Mendoza.
Remind me one thing. Is there any timeline for that? What was
ready.
Yeah, so it's not
right.
So it's not like a given timeline. It's like whenever we're ready kind of thing, isn't it?
Yeah, it is. Specifically for Valhalla, though, Brian Getz created an abstract timeline. He said, there was like there are different prototypes. The first one was called Q World, and that didn't work out that well. And so the new one is L World now, and that's the L. If you know bytecode, if you know, is it bytecode even? Damn, now I'm out of my depth. So anything, but sometimes you see in Java error messages, right? The L before classes.
Yes.
That's that L, that descriptor, the type descriptor I'm talking about there. So that's why it's called L World. And what he said is L1 was the first prototype. L100 will be like everything is perfect and migration and specialization, and we get all of that.
Yeah.
And we're moving, he said, like it's a logarithmic thing, right? We're moving logarithmic stuff. So now we got to L2, which is the second prototype, which you can already test, by the way. So if you have any application that does intense computations, you can already now download the Valhalla prototype, and then you can transform some of your most critical types into values, and you can observe performance.
See how it behaves.
You still get boxing though, but if you can sneak that past the generics, then you can actually see how much faster this application get.
Yeah.
And that is important feedback to the Oracle team. Once again, if you tend to hear about features later and then be unhappy in how they turned out, if you think that about value tabs, then now is your chance to give feedback, to chime in and say, I tried this. Not just come with an opinion like I often do, like actually have tried that and give numbers is so much more valuable. We have an application that does X and we improve performance by 10%, which was less than we expected. That would be great feedback.
Yeah.
So we move in these logarithmic steps. We're at L2 now, and I think L10 is where we will see the first early access preview feature kind of release for some part of that. I think he said, I'm not sure. So we're moving. But honestly, I don't think that we'll see Valhalla before the next LTS.
Yeah.
We might see Loom before the next LTS, and I'm pretty sure that Amber will have a couple of results before the next LTS. But I mean, just basically the LTS is really just a random point in time. But just that's my guesswork.
It's probably it's a good kind of thing to hook onto, right? I guess. Okay, that's really good, and thank you.
We didn't talk about the APIs yet. There's so many APIs I can tell you in detail about all. But we just talked about language changes. There's so many more things. Reactive streams, reactive HTTP2 client. Let me see whether I can up with more. There are more collection factory methods, which I already mentioned in Sandra's video. Small changes to streams, to optionals. There's so many small and big things that happened since Java 8.
Right.
Don't do something because of fear of missing out, but you would be missing out if you wouldn't be using those.
So no pressure, but right?
No pressure. But
Okay, that's amazing. Thank you very much for coming, and thank you for agreeing to chat with me and our listeners.
Yeah.
I guess we'll thank you as well.
Yeah, thank you very much for letting me rail for 40 minutes. That was fun to be there. It was fun to talk to you about that. Yeah. And if you're interested in more of that, I have a blog, I have a Twitter account, and I think so does this podcast.
Yes.
Do you have more? Does computers do more? Do you have a blog as well? Company?
We do have a blog. We do have on Medium.
I'm sure it's great.
We'll try to add some links and stuff like that, and at the end of the and in the description of the talk as well. And see you soon in our next podcast coming near you somewhere at some point very, very soon. All right. Bye-bye. Thanks.